Today is the lecture of electrochemistry chapter. This is the class content will be the conductance. Okay, basically we will discuss the conductance about the conductance in this class. So first of all, we will know about the conductance. What is the conductance? Okay, so basically the conductance means conductance. So before going to the conductance term, okay, we have to know about the resistance, the resistivity. So in electrochemistry chapter we have knowledge about the current. Okay, we have the knowledge about the current. So basically the current is means the flow of the electrons. Okay, so in a copper wire there is the lots of electron is flowing. Yeah, in a electrochemical cell there are two copper wire is there. Okay, so from the one half cell to another half cell, electron is the flowing to left to right side. Then the current the flow will be the opposite side, right to left. So basically the flow, the direction of the flow of the current and the flow of the electrons will be opposite. Okay, so the current means, so here we will write here the current means the flow of electron. Now which type of the things in nature, in chemistry, that will the flow, that actually the flow the metal, like the copper, platinum is there. So there are the various type of the metal, they can flow the electrons. That means they are able to bear the current. Okay, they can do the flow the current from the one side to the another side. So this is the current. The current means the flow of the electrons. Now how the conductance term is coming? So the conductance means basically this term from if we go to the resistance terms form, first of all we will go resistance. The resistance means there is some opposite force. There is some opposite force. This is the opposite force, basically opposite force to current. Okay, so there is, suppose this is a copper wire is there. So here the current is flowing this way. Okay, but there are the some resistance. So resistance, what will do that here? The resistance do not want to flow the current. So the resistance will act as the opposite direction of the current. Okay, so suppose I am thinking about that this is a copper wire. So this is a copper wire. So in this copper wire, so this copper wire, the length is L. The length is the L, and this cross section area of this copper wire is the A. Okay, now there is a law that the resistance depends on, it is the proportional to the L. That means when the length of the copper wire will be the length of the copper wire, when the length of the copper wire will be increased, then the resistance also the increased. But when the cross sectional area, this cross sectional area of this copper wire will be the increased, then the resistance will be the decrease. Okay, so this is, so the resistance is proportional to the length, but the resistance is not proportional to the cross sectional area. Okay, so if we write here the resistance the R, so R is proportional to L by A. So here the R equal to rho into L by A. So here the R equal to resistance, L equal to the length of the copper wire, A equal to the cross sectional area. So the rho equal to, rho is called resistivity. So it is called the resistivity. Okay, so this is actually a constant term. This is a constant term. Okay, so it is called the resistivity. Now from the terms of the resistivity we will go to the conductance. So the conductance mean, what is mean by conductance? So the conductance means, so the inverse of resistance is called conductance. That is basically denoted by the G. So the G equal to 1 by R. So we know that R equal to rho into L by A. So it is a rho into L by of A. So if we simplifies, it is a 1 by rho into A by L. Okay. So now, so the conductance means the inverse of the resistance. The inverse of the resistance is called the conductance. Now, so what is here? The G equal to 1 by rho into A by L. Now 1 by rho, if we write here K into A by L. So this K is called, that is called conductivity. That is called the conductivity. Okay, so this is called the conductivity. So now what we here learned about that, if we write the again the law, only the law, so what is there? First of all, the R varies 1 by, sorry, L by A. So from that law, that equal to rho into L by A. So here the R equal to the resistance, that's units basically ohm. Okay, so that's units basically in SI unit, basically the ohm. Okay, that is measured in ohm, which is in terms of the SI base unit. Okay, so that is the ohm. Now, so this is the ohm. Now in SI unit, if we write that, so R equal to rho into L by A. So what is the rho? So rho equal to R into A by L. Okay, so if we write the unit of the rho, so this is the resistivity. So what will be the unit of the resistivity? So the resistivity unit will be, so R unit equal to the ohm. So this is the ohm. Now in SI unit, so this is the cross sectional area. Suppose this is the meter square and this is the meter. So it will be ohm into meter. So in SI unit, in SI, in SI, the unit of the resistivity equal to ohm into meter. Now, if we write this ohm into, so this is in the SI unit. Okay, but in, if we write that is the semi, so this will be the 100 ohm into semi. Okay, so this is the 100 ohm into semi. So this is the unit of the resistance and the resistivity. Now if I go to the unit for the conductance, so what will be that? So we know that the conductance G equal to inverse of the resistance. So what will be this unit? The unit will be ohm inverse, ohm inverse, or like that. Okay, so the units of the conductance will be ohm inverse. Now what will be the unit of the conductivity? Now what will be the unit of the conductivity? So we know that G equal to 1 by R. Okay, so what is the R? So R equal to, so rho into L by A. So that means the 1 by rho into A by L. So that is the conductivity. So conductivity equal to 1 by rho. So we know that the units of the rho, so units of the rho equal to ohm into meter. So what will be the units of for the conductivity? So the units will be ohm inverse into meter inverse. But in semi, it will be the ohm inverse into semi inverse. Okay. So 1 meter equal to 100. So into 100. So in this way we have to think about it. Okay. So these are the law, these are the very important law about the conductance, about the resistance, the resistivity and the conductivity, and these are the unit. Okay, so these are the very important things. So now, according to the conductivity value, okay, so the conductivity value is the, that one is the, so this is the conductance, so G is the conductance and K equal to the conductivity. Okay, so according to this conductivity value, we can classify, we can classify, there are the various type of the materials. Okay, so there is the classification of the materials according to the value of the conductivity of some selected materials at 298 Kelvin temperature. So this is the value where we can see that, so these are the materials. So according to this conductivity value, so these are the conductivity values. ঠিক আছে? So these are the conductivity value. So according to this conductivity value, okay, so the materials are divided into basically the four categories. One is the conductors, second is the insulator, and third is the semiconductors, and this is the aqueous solution. So what is that? That is a very important. Basically, which are the metals? They are have the large conductivity value. If you see that the sodium has the conductivity value 2.1 into 10 to the power 3, copper has the 5.9 into 10 to the power 3, silver 6.2. So these are the metals which have the high conductivity value. So when which the metals will have the high conductivity value, this materials is called the conductors. So that means that when these are the high value, so when they are the giving the high conductivity value, that means they are very capable, they are the very capable to flow the electrons. Okay, so that's why they are called the conductors. But whence we will see there are the very low value of the conductivity, it is the 10 to the power minus 16, 10 to the power minus 18. That means they are not able to, flow of the electron, flow of the current. Okay, so they are not conductors, they are the insulator. Okay, like the glass, like the Teflon, and also I will wood, I will add the wood. So these are the actual insulator, they are not able to flow of the current. Okay, if we touch the glass with this copper wire, which is the able to the current, so we will not the shocked, because the glass and the Teflon and the wood are not able to flow of the current, because it has the low conductivity value. It is the has the 10 to the power minus 16, 10 to the power minus 18 order. So that's why they are called the insulator. Okay, so there are the extreme point, there are the two extreme materials, one is the conductors and that is the insulator. Between this insulator and the conductors, when we will see some value, some conductivity value, which is the lies the between the conductors and the semiconductors, then we will say it is a semiconductors. So these are the semiconductors. If you see the value, 10 to the power minus 7, 10 to the power minus 2, 2.0. So these are the value which the lie between the conductor's value and the insulator's value, and they are called the semiconductors. And these are the materials, basically these are the materials can flow the electrons, they can flow the current, but not so much as the conductors. Okay, so that's why they are called the semiconductors. Now if you see the aqueous solution, okay, so in this, so these are actually not the materials. Okay, so basically in according to the conductivity value, if we divided the materials, so these are the conductors, second is semiconductors, and third is insulator. Okay, so these are the three types of the materials according to the conductivity value we can classify. But from where this aqueous solution is coming? Because if you see the water, okay, basically we know that water can flow the electrons. Water is a conductors because waters can flow the current. Okay, if we touch the current with this water, so we can get the shock because the water has a conductivity of the current. But if we get, suppose we are getting a pure water, okay, so in the universe, so there are the nothing is there which are the 100% pure. Okay, so if we get the pure water, we will have the some H plus and the H minus ion. So in this pure water, if we dissolve the NaCl, this is the strong electrolyte. Okay, if you dissolve the KCl, so if we dissolve this type of the strong electrolyte, then the mixture of the NaCl and the KCl aqueous solution will act as a conductors. Okay, they can flow the current from the one side to the another side. So this is actually this is a solution type of, this is the aqueous solutions where we are adding the strong electrolyte and the weak electrolytes depends on their the dissociation constant. Okay, so this is the aqueous solutions of the strong electrolyte and the weak electrolytes. Okay, so when we are adding this type of the electrolyte from the outside to this pure water, then this aqueous solution act as a conductors. Okay, so these are the value, there are the various type of the aqueous solution is there. Okay, so these are the value. Okay, now what is means this value? So if you see this pure water showing the conductivity value 3.5 into 10 to the power minus 5. So it is actually low conduct. Okay, so value is the very low, 10 to the power minus 5. So pure water is not able to the flow of the current. But if you go to the strong electrolyte, like if we go ACl, KCl, NaCl, so these are the strong electrolyte. When we are adding this type of the strong electrolyte to this aqueous solution, then the conductivity value is going to positive and it is going to 3.91, 0.12, 0.12. So this type of the solutions are able to flow the current. Okay, so these are the things. Okay, so basically there are the different types of the conductivity value. Okay, so based on the conductivity value, we can divide materials, the conductors, insulator and the semiconductors. Okay, now there are the some importance point. Okay, so depends on this point, they this type of the materials, this type of the metals giving the conductance value. So so the conductance, this is the G, varies just 1 by R for resistance. So G equal to rho into G equal to K into 1 by R. Okay, so K is the conductivity and G is the conductance, and here the R equal to the resistance. Now this conductance value, this conductivity value, okay, so this conductivity value like the dissociation constant, okay, like the dissociation constant value, so this conductivity value depends on some points, the nature and structure of the metal, because we know that the material, this metals is actually conductor. Okay, so the nature and the structure decide the conductivity value. Then we know that this current means, actually the current means, already I have said the current means the flow of electron. Okay, so when the number of electrons will be more, then the current also will be the more. Okay, so the conductivity value depends on the number of valence electron per atom. Okay, and there are another points, temperature. The temperatures, it's when it decrease with this increase of temperature. That means conductivity value, this conductivity value, this is the K value, is in proportional to the temperature. Okay, when the temperature is increased, then the conductivity value will be the decrease. Because why I am saying that, basically what happened here. So this is a suppose a metal. So this is a suppose a sodium metal. Okay, it has the lots of electrons there. Okay, so we know that the conductance, the conductivity value depends on the electrons, the flow of the electrons, basically the number of the electrons. So when we increase the temperatures, when we will increase the temperatures, then the entropy of these electrons will be the increased. Okay, so then what will be happened here? Suppose the temperature is normal. Okay, when the temperature is normal, then the electron is flowing in this direction. In this direction, suppose the electron is the flowing in this direction, so we will get the current. That is no problem. But when we are increasing the temperature, then the entropy of these electrons will be also the increased. When the entropy of the electrons will be increased, then the one electrons will goes in this way, another electrons will goes in this way, another electrons will goes in this way. So there will be the no symmetric flow of the electron. So the flow of the electrons will be the asymmetric. So in this, that's why when we are increasing the temperature, then the conductivity's value actually gradually decreasing. So this is the some points, based on the points, based on this value, we will say the some conductivity value. Now I am going to the ionic conductance. What is the ionic conductance? Ionic conductance actually basically for aqueous solution. Already I have said that for a pure water, if you take a pure water, you will basically not, it is not actually good for the conductivity because it has the less value. Hence we will add the some electrolyte, NaCl, KCl or HCl or the NOH. So this type of the strong electrolyte when we will add to these materials. Okay, so when we are adding some electrolyte, like the strong electrolyte NaCl, KCl, NOH, so this type of the electrolyte when we are adding to the aqueous solution, then these aqueous solutions will show some conductivity. Okay, so according to this, so that is called actually the ionic conductance. Why we are saying that is the ionic conductance? Because in this conductance, in this conductivity, the ion is involved. Okay, here the Na plus Cl minus, potassium plus Cl minus, Na plus OH. So this type of the ions are the involved in this conductivity. So that's why it is called a ionic conductance. So this ionic conductance value also depends on important points like the nature of the electrolyte added, the nature of electrolyte, because we can add the strong electrolyte, also we can add the weak electrolyte. If you add the strong electrolyte, we will get the high conductivity value. If you add the weak electrolyte, so we will get the weak electrolyte, we will get the low conductivity value. So that's why the nature of the electrolyte is a very important. Another point is the size of the ions the produced and their the solvation. So size of ion and their solvation, because if you add the small cations, small anions, or the bigger ion, bigger, and actually basically that is the not fact. So the size of the ions, basically the number of the electrons, and the solvation also the most important, because if you add the some electrolyte but it is not a soluble, okay, so this partially soluble or the insoluble aqueous solution will be not able to the flow of the current, so it will show the low conductivity value. So that's why the solvations value is the most important. Then also another point is the nature of solvent and also its viscosity. Fourth point is always temperature, uh, concentration of electrolyte and the temperature. Here it increase the temperature, we will get the increase the conductivity value, because here actually basically what is the fact? So this ionic conductance, the fact is that there is aqueous solutions will have the cations, will have the anions. Okay, if you increase the temperature, okay, so then suppose so there are the some electrolyte is there which are the not soluble in room temperature. If you add the some temperature from the outside, they are the soluble. Okay, so temperature here with this conductance value, this the conductance is proportional to the temperature for that ionic conductance, but for the electrical conductance, for metallic conductance value is totally in proportional to the temperature. So this is the fact. Okay, so there are the some points which is the very important. Cell constant. Here the cell constant is defined G star. G is the conductance, G star equal to the cell constant. So now what is the cell constant? The cell constant basically the ratio of L by A. So G star equal to L by A, it is called a cell constant. Okay, so if you see the unit like the SI unit is meter per meter square, so the unit equal to the meter inverse. So the constant, so the unit of the cell constant equal to the meter inverse. Okay, so now also this is the cell constant. Now we know that G equal to is the conductance value 1 by R. Okay, it is the inverse of the 1 by R, and also so from that value also, and also we know that also the R equal to rho into L by of A. Okay, so L by A equal to G star. So G star equal to R by rho. Okay, now 1 by rho, we know that the conduct, so that equal to 1 by rho. So R into K. So cell constant G star equal to R into K. So K equal to the conductivity, rho equal to the resistivity. Okay, rho is the resistivity and K equal to conductivity. So basically what is happening here? Conductance G equal to 1 by R. Okay, so this is the conductance. So this is the conductance, and the conductivity K equal to 1 by rho. Okay, so R for the resistance and rho for the resistivity. Okay, so the cell constant G star equal to R into K. So K equal to conductivity and R equal to resistance. Now, so what is happening if we have the some importance value? This is the molar conductivity. What is the molar conductivity? If we write here, it is a very important thing. Molar conductivity equal to chi of M. Okay, so chi M equal to molar conductivity equal to, So conductivity, that means, so this is the conductivity, so this is the conductivity by C. Here are the concentrations. So C equal to concentrations. Basically, the C concentrations will be, what will be? So the concentrations will be mole into 3. But that means the mole per meter cube. How this meter cube term is coming? Okay, basically it will be the moles per liter, but the meter cube is coming. So if you see the concentration equal to, actually this is a molarity, so moles per liter it could be, but we are writing meter cube because here the length of the copper wire, the length of the copper wire equal to 1 meter, and this diameter also meter square. So this is the cross sectional area. So this cross sectional area equal to 1 meter square, length also 1 meter. So the volume will be the meter cube. Okay, we know that the concentration equal to, the concentrations equal to weight by volume. So here we are describing the weight as a mole per volume. So moles into meter cube. Okay. So here I will write, if I write here, so the molar conductivity chi m equal to conductance, this is the conductivity value, by C. Okay. So now what will be the unit like that? So the chi equal to Siemens into meter inverse. Okay. Siemens into meter inverse, and also the concentration equal to moles into m to the power minus 3, moles into m to the power minus 3. So here concentration terms will be moles into m to the power minus 3. Now if we write here, it is a very important thing how we will change this term actually. So once moles into meter minus 3 equal to, we can write like that actually. So 1000 liter per meter cube into molarity. That means molarity, we know that this is the moles per liter. Molarity means the moles per liter. So liter is cancelled out. So we are getting actually 100 into molarity into mole into m to the minus 3. So if we write here conductivity is minus 1, so in this terms we can write here that one actually. Okay, so that will be the 100 liter m to the power minus 3 into molarity. Okay, molarity means this is the concentration, mole into liter inverse. Okay, in this, in that thing, if you write also if you go to this term here 100, so then this unit will be changed, molarity moles into liter inverse. So here the Km equal to K into 1000 by C. If you write the law, this molar conductance in without the unit, so the conductance value will be the molar conductance value will be the molar conductance equal to conductivity value into 1000 by C. C is the concentration, K equal to the conductivity value. Okay, and this C actually molarity, moles per liter. Okay, so to calm the liter term, that's why we are multiply into 1000 into 1000. Okay, so according to this, whatever I have taught here, based on that I will solve the two problem. This is a very important thing. If you read this problem, the resistance of the conductivity cell filled with 0.1 mole into liter inverse. So this is the concentration. KCl solution. So it is a aqueous solution, aqueous KCl solution, which is the concentration. So the concentration equal to 0.1 mole into liter inverse is the conduct. So the conductivity is said. So conductivity is said. So conductivity means that is the G. Sorry, resistance. Resistance is said 100 ohm. So R equal to 100 ohm. Okay. If the resistance of the same cell, so the cell is the same, when it's filled with the 0.02 mole into liter inverse KCl solution 5210. Okay, so suppose this is the R1, so another cell, so suppose this is the C1, so another aqueous solution where the resistance value will be 520 ohm, then the concentration will be 0.2 mole into liter inverse. So this is a one cell and this is a one cell. Okay, so there is the two different type of the so the cell is the same but the concentrations is the different. So this is a one cell, this is a one electrolyte cell where the concentration equal to 0.1 mole into liter inverse and resistance equal to 100 ohm. But there is another cell which has the concentration 0.2 mole into liter inverse and resistance equal to 5210 ohm. Okay, so now calculate the conductivity and the molar conductivity that cell. So what will be the conductivity value and the molar conductivity value? So conductivity means here we have to determine, and molar conductivity that's mean that's one. So these two value we have to determine. So here if you see cell constant, we will come to the cell constant value. Okay, and also it is written that the conductivity of the 0.1, so this cell has the conductivity value, so the conductivity G1 value equal to 1.29 Siemens per meter. Okay, so this is the conductivity value. So first we will find out the cell constant value G star equal to, we know that the cell constant equal to conductivity into resistance. Conductivity, that means the G1 into resistance R1. So G1 equal to 1.29 into meter inverse, resistance equal to the 100 ohm. Okay, so what will be the value? And we know that that one is the inverse term, so it will be cancel out, and that will be 129 meter inverse. So the cell constant value equal to 129 meter inverse. Now it is saying the same cell. So same cells means the cell constant value will be same. So in that sense, the G star value also of that concentrate of that the aqueous solution 129 meter inverse. Okay, so now the conductivity value, we know that the conductivity, so the G star equal to conductivity K into R. So here it will be the R2, suppose it's the K2. So the conductivity, the K2 equal to G star. Okay, so here we can in this way we can also calculate the conductivity, this is the K2, and also we can calculate the molar conductance value, is the Km. So this is the molar conductance. So there is the another question, this is the very important thing. So in this question we can see the everything, the electrical conductance. So the electrical conductance of a cell, which is the concentration term, which has the concentration term the C equal to 0.05 mole into liter inverse. Okay, so this is a aqueous solution where the strong electrolyte is used. This is the NOH solution. Okay, so which has the diameter, here it is a wrong written, so it will be the 0.5 actually. So the diameter equal to, it is a written, so 0.5 semi, and the length will be, the length is there, and this is the 50 semi. Okay, so and the electrical resistance is given. So the resistance, that means the R, it is given 5.55 into 10 to the power 3 ohm. Okay, so if you from that value you have to the calculate the resistivity. So that means the rho we have to calculate it, and also the conductivity, that means the K we have to calculate it, and the molar conductivity, that means Km, we have to calculate it. So first we will calculate the resistivity. So we know that the R equal to rho into L by A. So in this thing, so rho equal to R into A by of L. So resistance is given 5.55 into 10 to the power 3 ohm into A, that means the cross sectional area. So A will be pi into R square. So pi value 3.14, R value 0.5 square. So that giving 0.785 semi square. Okay, so A value will be 0.785 semi square, and the length, this is the L is given the 50 semi. So if you calculate this value, it will have the value 87.135 ohm into semi. So this is a resistivity. So this is the resistivity. Now if I go to the conductivity, we know that conductivity equal to 1 by rho. So it is the inverse of the rho. So 87.135 ohm into semi. So the value will be 0.01148 ohm inverse into semi inverse. Okay, we can write also that term Siemens into semi inverse. Okay, so we know that conductivity value, also we know that the concentration. So from that two value we can calculate the molar conductance chi m equal to conductivity into 1000 by C. If you put this value 0.01148 into 1000 into 1000, and the concentration will be 0.05, so it will give the value 229.6 Siemens semi square into mole inverse. So in this way we have to calculate the conductivity value, molar conductance value for the ionic conductance, which are the various point that are the dependent. So in this way we have to calculate it, the resistance and the resistivity. That's one. So here I will stop the class. Okay, thank you.